folks, welcome back to the Philosophy of Data Science podcast series. This is the next episode in our session 1, in which we're introducing the value of scientific reasoning for the practice of data science. We have a very cool guest today, Kathy Ensor at Rice University, and a future ASA president. And she'll be talking about why scientific reasoning and going through these steps is very useful to help distinguish yourself as a professional. So some of the more human reasons why it's good to be going through and be comfortable with these topics. So Kathy, welcome to the series. Thanks for showing up and being one of our headlining speakers. Maybe we should just start off by you introducing yourself and your variety of research interests. You have quite a few interests.
I do. I have a wide range of interest, and data science and statistics allows that. So that's a perfect area for me. So Glenn, first of all, thank you for putting this series together. Thank you for including me in this very important opening. And thank you to the audience for tuning in. And hopefully that some of the things that I say resonate with you and you find value in today. So my name is Kathy Ensor. I'm the Noah Harding Professor of Statistics at Rice University. And I was one of the founding members of the Department of Statistics so many years ago. At Rice, the statistics department actually sits in the School of Engineering. And so I think we predated this sort of data science growth and expansion and excitement. And I feel very strongly that myself and my colleagues have been part of the growth and expansion in this wonderful area. So my research area, again, interests are wide, but from a methodological perspective, I'm interested in dependent data like time series, spatial processes, high dimensional data. I have a deep interest in stochastic processes and the applications of stochastic processes to real problems. And I do develop methodologies along these lines, but over my career, I've definitely migrated towards solving real problems. And so I am a very good practical statistician and data scientist, focusing my interest in, focus is not a correct word, but applying my interest to a wide range of opportunities. So I do also at Rice direct the Center for Computational Finance. And so I lead a research team and student effort around quantitative finance. Definitely data science has changed the field of finance, and some of it for the better, some of it not. And our goal at Rice is to contribute to the better part of how quantitative methods can improve the financial infrastructure globally. I also have a really strong interest in environment and then how the environment impacts health. And so if you look at my research portfolio, you'll see many applications around that arena. And I do invite you to go to my website, ensor.rice.edu, and you can see all of these different areas where I interact. But
so your new fancy website. It's new or fancy.
Fancy website, that's right. So everybody should have a new fancy website, so keep your website up and going. So from an environmental perspective, being in Houston gives me lots of opportunities to engage and to help mitigate any challenges that might be experienced in our community. So I work strongly with the city and county governments that surround us. And so having done this for 20 plus years, I have started to package that into the phrase urban analytics. So how can we use our data science and statistics tools to help improve our urban environments? So that's probably a pretty good introduction to the kinds of things that I do. Should I add more? Or?
I think it covers it pretty well, especially the most important thing that people should realize is that the best statisticians and data scientists work on stochastic processes for time series with healthcare applications. And I think that's the real thing that everyone should take into account, that the best of us all, it's time series, stochastic processes, healthcare. What more could you ask for?
Well, you got to put spatial in there. I'm very big on the geospatial information. So that's the one more that you could ask for. So
I don't know, that is a few extra dimensions. Yeah, cool. So maybe we should just jump right into it. And the main question is scientific reasoning, because that's what the series is about, scientific reasoning. Is it worth learning? Is it esoteric or is it useful? And so should a data scientist really invest their time watching a series talking about scientific reasoning? We like to think that we're all very good scientific reasoners, but the fact is it is a practice, it's a learned skill.
That's right. And from my perspective, it's foundational. And so absolutely, we should not only invest our time now, but continually re-educating ourselves on the strength and importance of scientific reasoning. So any of us can learn to program and to produce things, but we need to understand what's behind what we're producing. And that's where your scientific reasoning comes in. And there isn't a problem that I enter into, whether it's finance, environment, looking at COVID-19 virus information, where the scientific reasoning behind the way that I'm going to approach the problem is foundational. So that is always my first step, not my last step in what's going on with the problem in hand. And so, just really investing yourself in learning what we all train ourselves to do, but sometimes we forget when, there's data coming in, we need to write these programs, we need to produce answers, but we need to step back and say, what data is coming in? What is the quality of the data? How is it selected? What does it actually represent? And, so sort of those core issues around sort of the data representation and what questions can be answered with that data. And just as importantly, what questions cannot be answered. And so, I do think we see maybe a slight void in that process of really sort of digging into the limitations and the data quality issues around the problems that we're studying. And so again, rolling that all into scientific reasoning and with the goal of ultimately making sound inferences and decisions from our data science process. So I would put this as top of the list, and I'm so excited about this series and what you're putting together, Glenn. And I just really hope that everyone engages with it and learns a lot from it. I look forward to participating as an audience member.
Yeah, and you've brought up one of the main sort of issues that I've glommed onto for one of the value of scientific reasoning, which is that it's once you're more familiar with the scientific process, in particular the ways that you can go wrong in your inference methods, that you do develop more of not just a technical understanding, but also an intuition about the limits and the extent to which your claims are valid. So one of the ways that I think that really, to me, what distinguishes the really interesting, more profound, more believable data scientists and statisticians in our field is that they do have a very strong appreciation about the bounds in which their contributions are actually still valid. And they are very good at delineating, well, this is an area where I don't think that we can really be applying this. I think that my method is only applicable up until this point, and on these populations and things like that. And that is a fundamental aspect of science, which is understanding what is not just what have we discovered, but what is the bound of that discovery beyond which we in fact need further information and further discovery.
I couldn't agree more. And especially like if you're working in time series, one of the aspects of time series is we want to forecast. So we want to say something about the future, and anything that we say about the future is based on what we observed in the past. And so we truly, truly need to nail down the limits to what we can say about the future. And if we can't do it, we can't expect other people to do it for us.
Yeah, definitely. Time series modeling is, I think, one of the most like scientifically unforgiving subjects. Like it's the jerk in the room. It's like the mean Socratic teacher who calls out students in undergrad and is like, as you read your text, it's one of those things where it's truly unforgiving. And I think it's one of those areas where if you want to amplify the scientific challenge of creating valid time series models, especially when you're doing things like automating those models and making sure that they're fitting without sort of the human hand tuning, things can go off the rails very quickly, and it's unforgiving if you are making missteps. And the main reason you make missteps is because you haven't validated your methods in a way such that you know where those missteps happen.
Yeah, that's correct. And possibly you made some modeling decisions that are driving your methodologies, and you haven't fully explored what those modeling decisions, the impact of those modeling decisions are. So that is absolutely crucial.
Now, sort of one, it sort of sounds like a petulant question, but I think it's something that it's really important for, especially young statisticians to hear is, do you consider yourself a scientist? And I think I know the answer to that. So I'll do the follow-up question. When did you start considering yourself explicitly a scientist, and why? Not just a statistician, but I'm Kathy the scientist.
Yes, yeah. I definitely consider myself a scientist, and with everything that comes with that, with all the responsibilities and sort of the obligations to share what I know to help our world. I mean, we spend a lot of time training ourselves, and so we need to use our skills as best we can. So when did I become a scientist? I was raised by scientists, so I think I never was not one. So I think I have always in my life been a scientist, and even at the point where scientific rigor would come into the conversations at the dinner table when you're growing up, so where are the assumptions and validations of what you're doing, but with a lot of passion and curiosity about scientific matters. And so for me, it was natural. And as I think, if we all look back on our early years, we could have gone many different directions in our field. I loved animals. I loved studying plants. I loved all aspects of different areas of science. The first time I looked through a telescope and saw the stars, I'm like, I'm going to be an astronomer. So we could all probably think back to exposures that we had to different areas of science. For me, I was always, I don't know if gifted is the right word, but serious mathematics was always very easy for me. And so it was very natural for me to start out in a mathematics direction. But then I knew I was a statistician when I looked to go to graduate school, and I said, where am I most likely to get a job post-graduate school? So what did I do? I grabbed some data on who's getting jobs and what are the opportunities in the field, and I just immediately, landed on the idea of becoming a statistician, and I've never looked back and regretted that decision. I was, as a undergraduate, always keenly, I think looking back, probably learned 4 programming languages as an undergraduate. And again, coupling with the mathematics, I fell in love with probability. And so all of those pieces that come together to make a statistician and now a data scientist just were very natural for me. And the other piece is the opportunity to engage with other scientific disciplines. So, again, I'm very broad in what I do, and I believe you really do have to understand something about these other fields to be able to properly bring your skills and your scientific reasoning to their challenges. But we're not limited. So we're as long as we're willing to engage in their scientific space, then it's there. And so I think I have always been one, and I will always be one.
Well, I guess actually then that leads to a little bit of a challenge because, if you're always been a scientist, I guess the next question though then is, what was your process for becoming a better scientist? So there's young Kathy at the dinner table, scientist growing up. And now there is Kathy Ensor, ASA, future ASA president. When did you realize how much left there is to learn? Because, part of it is that growth process. Many of us, when we come from a technical background, we have that natural, logical scientific approach, but there's the rigor in the experimental design and those types of things, that sort of more inductive process, which is a learning process for everyone. So do you have some sort of standout learning experiences that helped you say, this is more important to my growth as a scientist, or this aspect is essential for me being a better scientist than I was yesterday?
Yeah, so I think I wake up with that question every day. I mean, I think I really do. And I think we probably all do. Every day we learn and we grow. Even as an undergraduate, I definitely found a niche as an undergraduate. I just really found a passion for the fundamentals of where we're headed. And then the opportunity to study at the PhD level, and then really learn how deep you have to dig in to really understand that rigor, learning the rigor behind the ultimate solutions to a problem that may, in the language that you're communicating them, not seem rigorous, but there's deep scientific rigor behind getting to that, that 2-sentence public statement that you make. And so there were excellent examples of that around me when studying for my PhD. And so I did try to learn from them in terms of to really understand, how do you take that, being really good at math, being passionate about writing computer code, and you turn that into something that helps a scientific problem advance. And I'm all for developing my methodologies in statistics and data science. I love doing that, but it's that one next step. It is a step. It's not an easy step to take what we know, this deep understanding that we have, and helping, engaging with other scientists to advance areas beyond statistics. And so I go, it's like a loop. So I will develop methodologies and then feed that into a practical problem, or I'll take a practical problem and do the best I can with it with the statistics and data science tools that I have available, but then recognize there's a piece that could have been better. And so then that will circle back, give me some more methodology to produce. And so, we wake up every day with that, and then how we spend our time, maybe changes through our career and our lifetime, which component gets more of our time, but the ideas never change.
Yeah, I think that's actually one thing that a lot of early career data scientists and people who work in essentially having to learn other people's algorithms to get their start, that they sort of miss out, that they see that they know some algorithms are more complicated than others. Some models are more complex and harder to understand than others. And they understand that these complex models are valued. But sometimes it gets a little bit lost that, these complex models are arising because there's a person behind it trying to address a specific scientific problem. and that current methods are not quite addressing, and that essentially what they're doing by creating these newer, more complex models, or simply different models, or in fact even simplifying models in some ways, that is an expression of the scientific process, that they're trying to have better ways to describe these phenomena that they're working with. And so I know that a lot of the times people get hung up on the technical elements because, well, if you don't know the technical elements, you're dead in the water. But at the same time, the reason those increased technical elements and increased complexity arose, it is because you're trying to express aspects of natural phenomena that are not actually captured by current methods. So it is, you are progressing the scientific field by progressing our ability to describe and explain these types of things. On the issue of the trade-off between sort of the technical element and the scientific element, what are some of the times are there times when it's more important to, be a better scientist than it is to have that technical ability? So where you would essentially be willing to trade off some of that technical ability to have a better grasp or appreciation of the scientific elements involved?
Sure. So I'm actually going to answer that with a yes, because if you're engaging, it depends on what problem you're engaging in. But if you're, like, for example, right now I am working with the City of Houston Health Department on several COVID-related projects. And it is most important that I am a scientist in the room. And then it's second that I'm a statistician, data scientist in the room. And so, and why I say that is that, one of the projects, there's 15 people, 15 high-level scientists from Houston is blessed with all of these wonderful research institutions, and so we have leaders in all respective fields from that sit in Houston, and so we meet as a group, and I have to be able to engage with them. I have to be able to understand, what they are bringing to the table and how they look at the problem. And that's where the science and the scientific reasoning is so core. And then I bring in my value in terms of, oh yes, you're getting this data, it has this limitations, it has this value. And so, but I'm speaking in scientific terms to them. And then in addition, there's the public health scientists that are in the room who are trying to translate what we're doing. Houston is a very progressive city that values science and scientific reasoning extremely well, and so like next week we have a report to the mayor where we will all be talking to the mayor, and so I have to be and much of what will be presented will ultimately have passed through my hands, because I am taking the data and producing the answers to the questions that we're trying to solve. But even getting to the data that comes to me, there's probably 20 scientific steps before there's ever a single data point produced. And so to be a part of this team, I had to be willing to engage as a scientist to understand their scientific challenges and opportunities. And ultimately, we're getting some really good information that's helping the city of Houston, manage through this pandemic. I can't, we're all doing the best we can, and my hats off to the city of Houston and county governments around us to really listen to their scientific teams. And so that's an example.
Just on the topic of scientific communication, since you have done quite a bit of it, and not just in a single field, but across a variety of fields, are there some general ideas about how you try to approach it? Obviously you do need to be engaging your fellow scientists on their domain level, which means that you do need to have a domain grasp. But are there also just more general scientific concerns that you think are more applicable across many domains? One thing that I found, for example, in healthcare is that, well, yes, we might be working in a variety of different domains. It's the same handful of problems that everyone's really worried about, when they're trying to create technical solutions. And so have you found that to be true? Are there some general guidelines or general approaches, things that you've noticed?
Sure. So on the side of scientific communication, I just first of all, I do feel strongly that you need to have a scientifically rigorous result to talk about. So in the background, you are dotting those I's, crossing those T's, doing that multiple times, and ensuring that your answers at the end of the day are correct. And that is where all of our technical training is so critical, because there are some, as we know, there are so many steps to just actually getting to a correct answer, or that the answer that you have is correct based on the assumptions that you've made. But then on the other side, you're not going to communicate any of that technical information to your audience, most likely. So you need to listen. You need to understand who you're speaking to and meet them at their interest level. You know, what conversation are they interested in? If they're interested in that technical conversation, be prepared to give it. But if their interest is in, you know, what is the takeaway? What is the limitations? You know, you've got to be ready to get it down to those 2 or 3 sentences. You know, that elevator speech that, you know, and it feels painful because you spent, you know, months making sure that that technical solution is correct and it's optimized, and you're answering the right question. And so you're boiling it down to this more simplistic statement. And I think, you know, like an example of where I really ran into this, and I learned this firsthand, is we did take on about a decade ago, we took on the issues of air quality and health. And so we had 2 health endpoints, one of asthma, one of cardiac arrest. It was a massive data science study with much, you know, many partners and several years worth of work. And it has had real endpoints. So we have a standing Houston specific alert that goes out from the health department that we developed based on all this rich information. But then we roll it out to the public, and it's something, you know, it's a statement of like, you know, there's a 10% increase in risk for an asthma attack or asthma event if the ozone levels are between here and here. So it's rolled into maybe like a 2 or 3 sentence statement, and those statements are on my website so you can see them. But even coming to those statements, there was so much communication that went around to how do we communicate this to the public and how do we use it. And so, you know, so you have to understand the audience that you're talking to. And I will say that well, let me brag about ASA, because I know that they've actually done this, but ASA has worked hard on making sure that statistics and data science is in the public realm. And so there's a lot of communication with reporters and sort of the public face of data science and statistics. And so, you know, having a conversation about how to frame our scientifically rigorous message, but in a way that is appreciated and accepted by the larger community. And that's a huge value. I mean, you know, if you can think public, you can think CEO or C-suite, you know, whoever you're communicating to, you do need to meet them at the communication level that they're interested in. I hope I answered what you asked.
Yeah, definitely. No, yeah, you certainly did. I was mainly thinking about your, you know, your 10% increase in risk example, because, of course, there's an asterisk next to that 10%, which you want everyone to read, which is like, Kathy didn't sleep for like 8 weeks while she tried to validate this over a year. Like, this cumulatively cost me a large portion of my life and my happiness and frustration. And like, really working to make sure that that's rigorous. And it might just be the difference between that rigor might be the difference between that report saying 10 versus 15 or 20% or 0% and someone doing something stupid. But, it gets it right 9 out of 10 times versus 99 out of 100 times. And so there are different ways where if you weren't rigorous, or whatever the limits of your scientific rigor were, the product drops off and no one cares about the work that you did. But you do need, for just your own professional reasons, need to be making sure that that's as accurate as possible. But yeah, it is funny where, yeah, you suffered for the whole project, and it is a little bit painful to say, I'm going to boil this down into 2 sentences and no one gets to hear about my suffering. And scientific anxiety over that. One thing that I wanted that you hit on though was, like this sort of sense of priorities, where you have to understand the sense of priorities of to whom you're communicating. But I think that one thing that also really distinguishes good statisticians is their sense of priorities about the scientific domain itself. So not just the people you're talking to, but how those priorities affect your technical work. And from your work that I've read, I have liked the reasoning behind it, because it reflected an appreciation of, we can't model everything, but we will go for these key elements. And so do you have some ideas on that, about how sort of your understanding of priorities affects your ability to do data science?
Sure. So first of all, I've learned in I've become wiser in my years, I guess, that I can't take on every problem. And so for example, you will not see anything in my CV on genomics, because that is a complicated field. There are half of my department might work in that area, and so I've listened and I've learned, and I know the scientific challenges that they have faced and they have met and they have contributed to, and I have so much respect for the area. But it's also, it's a learning curve, and I chose not to learn that curve. So I chiseled out domains where I felt like I could really understand those domains of science so that I could make the strongest data science and statistical contributions that I could. Now I do stretch those domains, but they always stay within sort of the risk, finance, environment, flooding. So I stay within sort of an area where I feel comfortable. The move into public health was a big one for me, and it took some dedicated time for me to learn what the biostatisticians and epidemiologists were doing. What was the state of their art, and how could what I know from a time series spatial processes person, stochastic processes, contribute to that conversation? And so I did make a decided move into that area, because I had an opportunity to make a real difference, and we have made a real difference. You can look at the change point on management of asthma in Houston, and it just warms my heart to know that I can contribute to people better able to manage this very basic disease that we have in our communities. So I didn't go in and say, oh, well, I know this. I can automatically just be the expert in the room. And, our field is so broad, and there's so many exciting new things that people do, that, it's up to us to stay sort of at the top level of those. And then when we do want to jump into an area, then we really try to learn a lot about it. And so that is sort of how I define my priorities. But I'm, if I see an opportunity to engage colleagues, not only at Rice, but around the world, in making connections with other scientists, then I'm definitely one of the people that helps to do that as well. So.
Yeah, I think you've hit on a really interesting point, which is, as statisticians, we are in a profession that really elevates expertise and expects expertise. And your goal is to become an expert when you work in this domain. And so there is obviously a big temptation, a big draw to say, try to be the expert in the room on everything. Especially because if you're frequently in rooms with few or no other statisticians, you're the best that they have. But I do like your discernment between that and just say, you know what, here's a realm in which I can contribute very strongly. Here are the areas where I can go into, where I can still contribute, where I have less of a learning curve. And then here are the areas where, I'm going to leave it to my other colleagues and just say, if that's the problem you need to solve, you're going to get your best return going to those other people. So I think that is really good. On the issue of sort of, and I think that one of the other things I picked out from what you said that I think is very important is that by staying in the field in which you're very comfortable, essentially somebody is getting a highly rigorous, highly experienced person in that field. So that they are getting the truly adept scientist at in these fields when they are working with you in your domain area. Do you think that's important for young statisticians, where to really, instead of trying to chase every opportunity, to say, I'm going to become very rigorous and very good, I'm going to become a very reliable person analyzing certain types of data on certain domains, and people will know that they can always come to me for those applications?
I do think it's important to do a self-assessment on where your interests lie. And, it also depends on where you find yourself. You might find yourself in a company where you really have to stretch widely to be able to, you have to be the expert on a wide range of topics. And but there's advantages to that as well. But you're going to rely on the larger community. You're going to have to be able to quickly pick up on the methodologies that have been developed in each of these sub areas that we have. But if you're, I'm an academic statistician, so I have the opportunity to self-select at some level. And so I've self-selected in areas where I have a passion and an interest. I could have developed passion and interest in other directions. But I do think that there is value to really knowing the areas of science in which you're connecting. And so for example, again, bringing up the finance, I lead this Center for Computational Finance. That was a very natural thing for me to do as a time series person. But I can tell you that finance is a very, very complex scientific area, but it's also incredibly important to our global economy, as we have lived through and we will live through again. And so to just think that I can just naively bring my methodology to that area without fundamentally understanding what's going on in the background, I don't think that that's where the value is. I think the value is sort of deeply understanding an area, and there's just not enough time in a day for us to deeply understand all areas of science. And so yes, so I do think that as a young person, you need to pick something. You need to pick broad enough areas and be nimble. Move through the areas as the opportunities arise. Maybe in 10 years, it'll be very important that we all contribute our skills to get to Mars, for example. Where is that talent pool going to come from? And so you do have to sort of pay attention to the value that you're bringing to society and adapt as needed. But don't try to do everything if you can avoid it.
One way that I think a lot of young statisticians can also distinguish themselves and start to appear as true professionals in their field, as opposed to people who are still in the learning process, is that they do understand the limitations of their own work. And usually the language of science and scientific reasoning is the way that they can distinguish themselves, because they can show that they fully grasp not only what they're doing, but why they're doing it. And understanding the shortcomings of their own work isn't a does not mean that their work is any less good or less valid. In fact, it means it's probably more validated because you have to validate your work in order to understand its shortcomings. And on the super practical issue, for example, job hunting, which is I view as a place where you basically have to really describe your value and what you're doing and why you're doing it. Do you have any thoughts on how sort of really being articulate on scientific reasoning can help people in the job hunt to impress either someone in academia? For example, if you're choosing a postdoc, you want an articulate postdoc because one, they're going to represent your lab well, which means it takes some effort of work off you. And also you can trust that their work and that they can go somewhere independently. And I think a lot of companies also, not in academia, but in companies, people look for that as well. Do you have any comments about that, about how being articulate in scientific reasoning can help you distinguish yourself, particularly, for example, getting a job?
Yes, I do. So I actually, for the last couple of years, I stood up a new program at Rice University that basically it's a university-wide postdoc program, and so I led that activity for the first 3 years to get it up and going. And so as part of that process, you know, the postdocs that we were interviewing crossed all fields of academia. And so the whole issue was to try to get leaders in respective disciplines, having them work together, to grow up together as postdocs, basically. And then that's seeding sort of this interdisciplinary research down the road. And so we developed this really nice interview process that had sort of the 20-minute it had 20 minutes, but 10 minutes of presentation and 10 minutes of questions. And so in 10 minutes, you have to explain your science to a broad set of academics. And so there might be someone from English, listening to someone from nanomaterials, listening to someone from statistics. But you don't dumb down the message. You present the importance of why you're doing what you're doing, and the importance of the rigor behind how you approach the problem. And then you are opened up for 10 minutes of questions from this very broad group who is seated with faculty that are ready to just hit those key questions. And it ended up being just a fabulous day. I mean, it was just a fabulous. The interview day was just a fabulous intellectual day, because we had these young people who are truly working on path-breaking research in all areas of domain that could communicate their message in a way that made me excited about everything that they were doing. And that's what you have to do. I mean, you have to sell the value of your work. And it's not, I know that part of the value that we bring is deep methodological development. I know that. And we need to hold tight to that, because that is needed. But we have to communicate why it's important that we started down this path of this deep methodological work, and what outcomes do we expect to come from that. And I haven't ever lived in the corporate world, so I don't know that I'm an expert. Most of my students actually do end up going into the corporate world, and are extremely successful. They end up in leadership roles in data science, or they are in leadership roles in data science around the country.
Wait, you're saying that your quantitative finance students end up in the corporate world? That's pretty hard to believe.
No, all of my students. I mean, they might not be quantitative finance, so I don't just work with quantitative finance students, but yes, I will have to say the students that sometimes they leave finance after going into that. They may stay in it for 5 years and then become biostatistician. I mean, our field allows that, right? It allows us to kind of move between areas. But they all leave after working with me on the I mean, we practice this. It's ingrained in our regular training how to communicate your value. And so so if you train yourself on this, and you surround yourself by a community that, how are you communicating your value, then it becomes easier. I mean, it really does become much more natural. But it wasn't natural to me at a young age. And so it was a skill that I had to develop. But I think actually I think maybe today people are better at communicating their value. I don't know. I'm just, this postdoc program, I'm just overwhelmed by how great it was to listen to all these emerging scientists over the last few years. Does that did I answer your question, or did I just ramble? I guess.
No, you certainly did answer your question. And I really appreciate, we have covered a lot of topics, and I think we covered them in a useful detail for people. Just before we go, should we do any final thoughts, comments, and suggestions? My only final comment is, it was not lost on me that you said that you picked up 4 programming languages in undergrad. And I was just thinking, it's like, I didn't even do that. And we have higher level programming languages these days. Like, it's way easier to pick up languages these days. So that was my 10 cents.
Yes. And so that's more, don't be afraid to learn. And I'm still not afraid to learn. I love R plus R Studio, and very happy to remain in that field, that arena for the duration. But, I'm also recognizing that I myself need to learn Python and be a little bit more nimble in that regard. And so we do, I think that is one point, is that you do always have to learn and improve. We are in a field that is rapidly changing. It will not be the same in 5 years as it is today. And so you want to adapt with that. But then also, we're in a really exciting area to be in, and it's just wonderful. I mean, I have never a day regretted my decision to go into this world, and I know that you won't either. And do the work to make yourself the expert in the room. Sell yourself. Make sure that you have a good public persona. I had to redo my website to run for president of ASA. I was very embarrassed when people started going to my website and like, oh, Kathy, it's like 5 years out of date. And so, my bad, right? That was not a good thing for me to do. And so, so be sure that you maintain your public professional persona. I have a LinkedIn page. I'm not quite as proud of it, but working on making myself prouder of my LinkedIn presence. But, we are living in this internet connected world. And so we need to sell ourselves in that arena as well. But most of all, just be happy that you're in this area and continue to grow, continue to learn. And I hope that you remain as excited about data science as I am today.
Yeah. So I think you've illustrated the great conundrum, which is that when advertising yourself, if you make your website too new and fancy, you start feeling bad about your LinkedIn profile.
Yeah, definitely. Yes. So.
Yeah, but I think, I guess a good sort of ending message is, yes, science is developing rapidly, and our field is developing rapidly. The nice thing about science is that it is our mechanism for self-correction and further learning and further iteration. And while science itself is rapidly changing, the scientific methods behind them are not changing. Our foundational methods are staying strong, they're staying with us, and those are our good guiding points by which we can then do better science in perpetuity.
Perfectly stated.
Great. Well, Kathy, thanks so much for your time today. I appreciate it. And enjoy your bright, flowery background at Rice University, and we'll catch up with you sometime soon.
All right. Thank you, Glenn. Bye-bye.
Bye. guys, it's Glenn. Thanks so much for listening to this most recent episode of the Philosophy of Data Science. I hope you enjoyed it. If you did, please consider leaving a like, a comment, and hitting that subscribe and bell button. We're a small channel and every bit helps. If you have a lab, a department, some students, or some colleagues who you think would enjoy this episode, please consider sending along. Again, every bit helps, and we really appreciate your word of mouth. Our next episode on the Philosophy of Data Science will be coming out 1 p.m. Eastern Time, Wednesday of next week, so we look forward to seeing you then. But if you can't wait to get more data science, machine learning, and statistical content, feel free to look around the rest of the channel. We have a large number of playlists, including things like machine learning for healthcare, ethics and AI, and things like that. So give a look around. There's plenty more content for you to enjoy. You can also check out our website to not only see past episodes, but what's coming up, and see who our sponsors are. Thank you to our sponsors for your support. Now, while the views discussed on the show typically range between extraordinary and mind-blowing, the stated views don't necessarily represent those of the host, our sponsors, my employer, your employer, the speaker's employer, or anyone else not saying those words. And as always, thank you so much for your time. I really appreciate it. See you next week.